Part 3. Multiplying and dividing radicals. We'll start with multiplying. Again, radicals are very similar to polynomials. When you multiply polynomials such as 2x and 5x, then you would just multiply coefficient by coefficient and variable by variable. So 2 times 5 would be 10, x times x is x squared. The same thing is true for when you're multiplying radicals. So, given the question 2 root 7 and 4 root 5, the solution is 8 root 35. How was this determined? Well, does the same thing work on radicals as polynomials? Well, if we multiplied the outsides, the coefficients by the coefficients, 2 times 4 does indeed give us 8. If we multiply radicand by radicand, 7 times 5 does indeed give us 35. So, sounds like it's the same process. So when multiplying radicals, multiply the coefficients and then multiply the radicands. Only radicals that have the same index can be multiplied. Okay, so again, notice that they are both square roots, so all good. Let's do some examples. Express in simplest form. Okay, so we have root 8 times root 2, so the coefficients would just be 1 times 1, which is 1. So we would have root of 8 times 2, because again, they both have the same index. 8 times 2 equals 16, so that becomes square root 16. The square root of 16, 16 is a perfect square, so the square root is 4. Okay, great. Just again, like polynomials, we have a monomial times a binomial, so you would multiply the monomial into both terms, so that becomes 2 root 3 times root 12 minus 2 root 3 times root 6. Okay, so outsides by outside, so 2 times 1 is 2. Root 3 times root 12 is root 36. Minus 2 root 3 times 6 is 18. Okay, 36, now we're going to simplify. Alright, 36 is a perfect square, so that becomes 2 times 6, the square root of 36. And 18 is 2 times 9 times 2. So 2 times 6 is 12, minus square root of 9 is 3. 3 times the 2 out front is 6. Remember, when you square root, it goes out front. And we can't square root the 2, so it has to stand with the root sign. Part C. When we square something, it means to multiply it by itself. So that's 5 root 3 plus 2 root 6 times 5 root 3 plus 2 root 6. Again, coefficients times coefficients, radicands times radicands. So, 5 times 5 is 25. Root 3 times root 3 is root 9. Okay, so those are my firsts. Now we're going to do ours. So 5 times 3, or 5 times 2, is 10. And this is all positives, because everybody's positive. Root 3 times 6 is 18. Good. Okay, and then we're going to do the inners. So 2 times 5 is 10. And again, 6 times 3 is 18. And lasts, 2 times 2 is 4, and root 36. Squish her in there. Okay, let's simplify. So root 9, 9 is a perfect square, so that becomes 25 times 3 plus 10 root 9 times 2 plus 10 root 9 times 2 plus 4 root of 36 is 6. Let's simplify a little more. 25 times 3 is 75. Okay, that becomes 10, square root of 9 is 3, so that becomes 30 root 2, plus, exact same thing, so 30 root 2, plus 4 times 6 is 24. Okay, one last step, collecting like terms. So 75 and 24 makes 99, plus 30 root 2 and 30 root 2, add the coefficients, make 60 root 2's. All right, let's move on to dividing. Given the following that needs to be simplified, 2 root 6 over 2 root 3, the answer is 2 root 2. How do we get this answer? Well, let's see if multiplication is like division. So, coefficients with coefficients, radicands with radicands. Let's see. 4 divided by 2 is 2, so that worked out. And under the root sign, we can rewrite that as root 6 over 3. Okay, because again, they both have the same index. So 6 divided by 3 is 2. So yes, indeed, it will work. Coefficients divided by coefficients and radicands divided by radicands. Again, only like radicands that have the same index can be divided, or only radicands, sorry, that have the same index can be divided. Let's do some more examples with division. So, root 48 over 3 root 6. So let's take a look at that. 6 divided by 3 is 2 root, and again we can go 48 divided by 6 under 1 root sign. 48 divided by 6 is 8, so that's 2 root 8, but 8 can be written as a mixed radical, so that would become 2 times root 4 times 2. The square root of 4 is 2, so that comes out front, so that becomes 2 times 4, 2 is 4, and I can't square root the 2, so it stays 4 root 2. Ooh, part B looks like fun. Okay, so when we're dividing fractions, we flip and multiply, so the front guy stays as is, root 51 over 20, and becomes times root 5 over 17. Okay, good. So we can write them as separate radicals. So that's root 51 over root 20 times root 5 over root 17. Now let's put things that might have something in common together. 51 is divisible by 17, and 5 and 20 would go together. So let's just rewrite that. As long as the top stay on top and the bottom stay on the bottom, you can move them around on the bottom. Okay, so root 51 over 17 times root 5 over 20. So that becomes root 3 times 1 over root 4, or root 1 over 4, okay? So the root 3 can't be simplified, but 1 over 4 is a perfect square, so that becomes times a half, so that's root 3 over 2. Okay, that was fun. Good thing I left lots of space for that one. Now, suppose you end up with something that is in the denominator that you can't divide, okay? So to simplify an expression that has a radical in the denominator could be rationalized. For an expression with a monomial square root denominator, multiply both the denominator and numerator by the radical term from the denominator. That will help us to rationalize or get rid of the root sign in the denominator. Because again, anything with a root sign is an irrational number. So to rationalize it means to get rid of the root. Okay, so here's our example. 5 over 2 root 3. Notice that I have root 3 in the denominator. Okay, so I'm going to get rid of it because it doesn't go into the 5 because there's no root on top. So we multiply both the top and the bottom by the root 3. So top times top, bottom times bottom. Root 3 times itself is just 3, so 3 times 2, that's where the 6 on the bottom is coming from. Okay, so root 3 times root 3 is root 9, which simplifies to just 3. So 3 times the 2 that was already here makes 6. And now notice that there is no radical in the bottom. This has been rationalized. Is the answer equivalent to the original expression? How can it be checked? Well, remember again that you can always write things as decimals. So on your calculator, just type in 5 divided by 2 root 3 in brackets and get the decimal. Do the same thing with 5 root 3 divided by 6. And you should get the same decimal in both cases, in which case you know that you have the right answer. Okay, so convert both to decimals. Okay, good. All right. Example 1, solve by rationalizing the denominator. So again, the denominator is root 6, so we're going to multiply both top and bottom by root 6. Now, why do we have to do top and bottom? Well, if you just take a look here at root 6 divided by root 6, that just equals 1. So we're timesing it by 1. 1 does not change its value. It only just is going to change how it looks. So coefficient by coefficient, negative 4 times the 1 in front of that root is negative 4. Root 15 times 6 is 90. Over root 6 times itself is just 6. Okay, and let's see if we can simplify that a little bit. 4 divided by 6, they have a common factor of 2, so that becomes negative 2 over 3. Root 90 becomes root 9 times 10. So I can square root that 9. So that's going to become negative 2 times 3 root 10, because 10 it does not have a perfect square in it, over 3. The 3's will cancel out, and you're left with negative 2 root 10. And again, take out your calculator and do it on there and see if you get the same decimal answers. Okay, number 2. Again, I have a monomial denominator with a radical, so I'm going to take and rationalize, or I can take and, I'm going to do it this way because 12 is divisible by 3 and so is 6. So we're going to separate, so 4 root 12 over 2 root 3 minus 10 root 6 over 2 root 3. And again, because they are both being divided by 2 root 3, I can separate them in this manner. Now I can divide. So 4 divided by 2 is 2. Root 12 divided by root 3 is root 4. 12 divided by 3 is 4. Okay, 10 divided by 2 is 5. And 6 divided by 3 is 2. So that's 5 root 2. Now I can simplify this further because 4 is a perfect square. The square root of 4 is 2. 2 times this 2 makes 4 minus 5 root 2. All right, this has been good times. A few key ideas you're going to need to remember. The product of two square roots is equal to the square root of the product. So if we go root 3 times root 2, it's equal to root 6. We just multiply the insides by the insides and the outsides by the outsides. The product of two mixed radicals is equal to the product of the rational numbers times the product of the radicals. So again, the rationals are the coefficients. So 3 times 5 is 15, and 2 times 7 is 14. The quotient of two square roots is equal to the square root of the quotient. So root 6 divided by root 2 is the same as the square root of 6 divided by 2, which is just equal to root 3. And same with mixed radicals, outside divided by outside, inside divided by inside. So 15 divided by 5 is 3, 14 divided by 7 is 2. Okay. And again, don't forget that you could also do this question by rationalizing the denominator. So I'll just show you that here. Over 5 root 7. So we can multiply both top and bottom by root 7. Okay, so I would get 15 root 98. Okay, 14 times 7 over 5, and root 7 times root 7 is just 7. Okay, good. Now we can simplify. So 5 and 15 cancel, so 5 goes into 15 3 times. 98 has a perfect square of 49 times 2, all over 7. Okay, square root of 49 is 7, so that becomes 3 times 7. I can't square root the 2, so it stays under the root sign, all over 7. And again, the 7's cancel to leave me with 3 root 2. So again, this is getting the exact same answer, but I did it by rationalizing the denominator. Okay, so you will be able to do either for pretty much any division question. Page 198, questions 3 through 5, 8, 10, 11, 13 A and C, 14 B and D, 16 and 19. Good to get lots of practice in. Show your teacher when you're done.